So what we're going to take a look at here is how we can perform certain operations on terms with square roots. Over here in the notes section, I've put kind of our guiding principles for how we're going to do this. When we add and subtract square roots, we're going to basically think of radicals like variables. We're going to basically apply the same rules that we would apply with variables, and we're going to combine like terms. So you can see we're going to do that in 1 and 2, and I'll get to that in just a second. When we're multiplying and dividing, we're going to use these two principles. One of them looks kind of familiar because we've talked about it before. I've written it kind of in the reverse order of the way I talked about it before, and it's that if I take the square root of a times the square root of b, then that's the same as doing the square root of a times b. So if I have two things that are separated in their own square roots getting multiplied together, I can put those two things under one big square root and multiply them together. And then the same thing works with dividing. If I have the square root of a divided by the square root of b, I can take that and put a divided by b under one big square root. But that would also go the other direction. If I have a divided by b under one big square root, I can break that up and do the square root of a and divide it by the square root of b. And then always remember to simplify whenever possible. So sometimes you'll be simplifying before you do the operation, before you add, subtract, multiply, or divide. Sometimes you also have to check to see if you can simplify after you do whatever operation it's describing here. So let's go ahead and take a look at this first one where it says the square root of 3 plus the square root of 3. Like I said over here, I said think of these radicals like they're variables combined like terms. What I mean by that is I see I have a square root of 3, and then I'm adding another square root of 3. If this said x plus x, you would know that that's going to give you 2x's, right? And x is a variable, it's a number whose value is maybe unknown. And so when we add two of those unknown numbers together, we just say we have two of those, 2x's. Well, this square root 3 is kind of like an x, right? I don't know exactly what the value of square root 3 is. I could type it in my calculator and it would tell me an approximation of what that square root 3 is. But just off the top of my head, I don't know what the square root of 3 is. But I know that if I take a square root of 3 and then I add another square root of 3, what I'm going to have is 2 square roots of 3. Just like if I do x plus x, I have 2x's. If I do square root 3 plus square root 3, then I have 2 square roots of 3. And that's just going to be what we're going to write as the simplified version of square root 3 plus square root 3. Now in the second example, you can see we're subtracting, and this time it doesn't look like they are like terms. I said over here, combine like terms. And what I mean by that is square roots of the same number. Square root 3 and square root 3, those are like terms. But here I have a square root 5 and I have a square root 125. I'm going to look at those and say those are not like terms because it's not the square root of the same number. 5 and 125 are two different numbers. But then remember it says always simplify when possible. If I look at this square root 125 and think, okay, that's the square root of 25 times 5, then that turns into 5 square root 5, right? Because the square root of 25 becomes this 5, and then the square root of 5 stays underneath this square root symbol. And now if I drop down this square root 5, now this says square root 5 minus, instead of square root 125, it's now minus 5 root 5. And so now I have like two kind of like terms, right? If this said y minus 5y, we would know that that's going to be negative 4y. Well, we have something similar here. We have a square root 5. If you need to say 1 square root 5, you could write it like that. 1 square root 5 minus 5 square roots of 5 is going to leave us negative 4 square roots of 5. Now, in the next few examples, we're going to be multiplying and dividing. Starting with number 3 here, I'm just multiplying the square root of 2 times the square root of 3. And so I'm just going to use this property here that says if I do the square root of a number times the square root of another number, what I can do is I can say this is the square root of those two numbers multiplied together. And that's going to be the square root of 6. And then that's as simple as I can get. Square root 6 is going to be my simplified version of square root 2 times square root 3. I would maybe check to see if I can simplify square root 6. But since the square root of 6, since that number 6 does not have any perfect square factors, there's no way to break it apart into a perfect square times some other number, that means I cannot simplify that. It's just going to be the square root of 6. Now in number 4 here, we can see it says 4 root 6 times negative square root 3. And what I think about with this one is this is kind of saying 4 times the square root of 6 times negative 1, that negative symbol in front of the square root 3 is like a negative 1, times the square root of 3. And so I kind of have 4 things getting multiplied together right here. The 4, the square root 6, the negative 1, and the square root 3. Like we talked about before, multiplication is commutative, so I could do these in any order. So I could rearrange it so it says 4 times negative 1 times square root 6 times square root 3. And then that's going to be negative 4 times the square root of 18. But the 18 can be thought of as 9 times 2, right? So this is now negative 4 times the square root of 9 times 2. I'm running out of space here a little bit. I'm going to try and write it pretty small. And that's going to be negative 4 times 3 times the square root of 2. Because the square root of 9 is going to turn into this 3. And then it's going to leave the square root of 2 by itself. And now if I clean this up, what I'll end up having is negative 12 square root 2. And remember, you could always check these by typing in this original expression in your calculator, type in what you end up with, and make sure you have the same thing. Make sure it equals the same thing when you hit that equal sign on your calculator. Finally, what we have is two problems using division, but that division looks different in each one. This one uses like the old-fashioned division sign. This one uses a fraction bar as division. So we're going to be using this property down here. For number 5, we're going to use it just the way it's written. When I divide two numbers, two square roots, I can take the square root of that quotient, that a divided by b, all underneath the same square root. So right here we're going to have the square root of 140 divided by 7. And then 140 divided by 7 is 20. Now we need to simplify that. We've actually already probably simplified the square root of 20 earlier. I'm going to look at that 20 as being 4 times 5. So then the square root of 4 turns into a 2. And then I have the square root 5 left underneath the square root. So the square root of 140 divided by the square root of 7 works out to be 2 root 5. This next example, you can see what we have is the square root of this fraction. And remember, a fraction means divided by. So we're going to actually kind of use this property but in reverse. What I have is I have the square root of a quotient, two numbers getting divided. So we're going to break that into each number having its own square root. So this is now going to look like the square root of 128 divided by the square root of 25. And the square root of 25 we know is going to be 5. But what about this square root 128? Well, square root 128 is the square root of 64 times 2. The biggest perfect square factor that 128 has is 64. It's 64 times 2. And then that square root 64 times 2 is going to turn into 8 times the square root of 2. So now that will become the numerator of my simplified answer right here. And what I end up with is 8 root 2 over 5. So this turned into the square root of 128 over square root 25. Square root 25 turned into 5. Square root 128 simplified into 8 root 2.